In the past, all the motion we've looked at so far assumes that an object can be treated as a point mass, with just one position, velocity, and acceleration, and which forces act on. We assume that all the mass is concentrated at one particular point, which we call the center of mass. For regularly shaped objects like spheres, it's obvious where the center of mass is. It's in the center. But for other objects, like people, it's not so easy to figure out where the center of mass is. It's probably in the middle somewhere, but exactly where is tricky. So, how could we define center of mass? Let's start by considering a system of two discrete point masses, A at position 1, 0, and B at position 7, 0, which both have mass m. Where would the center of mass in this case be? Well, in this case, the center of mass would be halfway between the two at 4, 0. Note COM stands for center of mass, so I think that that's fairly intuitive. But the question is, what if B had double the mass of A? So, A has mass m and B has mass 2m. Now where would the center of mass be? Well, clearly it would be closer to B now, but the question is how much closer? The answer is it should be twice as close to B as it would be to A. So therefore the center of mass is at 5, 0. But why? Let's consider the average position of two masses. How we do this algebraically? Note, we're going to use vectors, so it's going to look like this. We're going to call R our position vector, and the position vector of the center of mass is equal to the position vector of the first mass, the mass of the first mass, plus the position of the second mass multiplied by the second mass. And then we're going to divide that by the total mass of the system. And that is our formula for calculating the center of mass of two objects. So let's try applying it to the previous scenarios. If we look at the most recent scenario where we had that the mass of B is equal to twice the mass of A, then our center of mass will be, so 1 in the x direction multiplied by the mass is equal to m, plus, so in this case for B we have 7 in the I direction multiplied by 2m, all divided by m plus 2m. And note our m's cancels out here, and the 3 and 15 also cancel out here. So we got the center of mass is 5 for that second scenario. I'll let you have a go trying to do the one where they have equal masses if you like. So, now you've learned the formula for how to find the center of mass for 2-point masses. Now the question is, what happens if we had more masses? Find out in the next video.